have prime factor decomposition for 100. If I tell you in a simple way, what are the prime factors that you are going to multiply together to get 100 as the answer? So how I'm going to do this? How I'm going to find out that? There are simple methods to use. One is they are telling you can have 2 to the power 2 multiplied by 5 to the power 5 or 5 to the power 2, which is going to be equal to 100. Now I'm going to show you all how to get this answer. There are two methods of finding the prime factor decomposition of a given number. That's the thing we are going to discuss now. First method is you all should understand factor trees, right? So the first method, they have given a separate new name for that, which is called as a factor trees. Now the given number is 36. Now I am going to find out prime factor decomposition of 36. How to do that? Under factor trees. First of all, you have 36, and what you are going to do here is you are going to think about two numbers which you are going to multiply to get 36 as the answer. So you all know 4 times 9 is equal to 36. Now the next is I have to include only prime factor if I am going to do this question. That is one important condition that you all should notice. So 4 and 9 are those prime numbers or prime factors? What you all think? 4, 9 are those prime numbers? No, isn't it? 4 and 9 are not coming under the category of prime numbers. So I cannot do like this. I have to do something more to this question. What? This is a tree. That means I can take this 4 and I can divide it into two parts. That means I know that 2 multiplied by 2 is equal to 4. And another thing is I know that 2 is a prime factor. So I can circle these two 2's I can circle. Now I am moving to the next number, 9. 9 I know it's not a prime factor. So again I have to break this 9 into two numbers. So I can take 3 multiplied by 3 as 9. So I know that 3 is a prime factor. So I can circle this 3 also. So now you can see 4 circles there. So now I got the answer. Now if you write all these numbers together with the multiplication symbol, this is what we call as prime factor decomposition using factor trees method. So you have two 2's, so I can write it as 2 to the power 2 and multiply by 3 to the power 2. So this is under factor trees we are working. Another method is there. They are telling 36 I can take in another way. How? 3 multiplied by 12. That is also going to be equal to 36. Now out of these two numbers, I know that 3 is a prime number. So I just circle that 3. Now I have to move to 12. I know that 12 is not a prime number. Now again I am going to break this 12 into two numbers. I can take 4 times 3. 4 times 3 is equal to 12, and this 3 is again a prime factor. Again I circle. Now I know that 4 is not a prime number. Again I have to divide that 4 into two parts. How? 2 multiplied by 2 equals 4. Now this 2 is a prime factor or prime number. I circled it. Again now after everything I can see all are finished. Now I can take everything and I can write as a multiplication. So finally I am getting the same answer. 36 is equal to 2 to the power 2 multiplied by 3 to the power 2. Or as 2 squared multiplied by 3 squared. That method is called, this method is called as factor trees. Right? So 2100, a big number, 4 digits number. Again, I'm going to use the same method. I know that 30 multiplied by 70 is equal to 2100. And now I'm going to break these numbers. 6 times 5 is 30 and 5 is a prime number. Now this 6 I'm going to break. I know that 2 times 3 is equal to 6. And both these numbers are prime. So after talking about 30, now I move into 70. 70 I can take as 7 multiplied by 10, and 7 is a prime number, so I can round it like this. Now I move into 10. 10 I can take as 2 times 5, and both these numbers are going to be prime numbers. Now after getting all those numbers, now I can write everything together like this. So final results I can write as 2 times you can see, so you can write as power 2, 3 1 time, so I am writing as it is. 5 2 times, that means 5 to the power 2 multiplied by 7. So if you multiply these everything together, you will get 2100 as the answer. So this method we are calling as factor trees, right? So after talking about factor trees, why they are giving the word trees mean, you all can see